Okay, so it's 2:30. Let's get started. Welcome to the second lab. Okay. So in this week, we are going to do measurement of SAVE analysis of sand and coarse aggregate, and also we do the oven dry bulk density of the coarse aggregate. Okay. This is lab number 2. Lab number 3, which is not next week, is the week after next week. Okay. It's also about aggregate. Okay, we're gonna measure the density of sand and coarse aggregate. Okay, so the lab report for the aggregate is to combine lab number 2 and number 3 into a single lab report. Okay, so every one of us will submit an individual lab report combining lab number 2 and number 3. Okay, so the due date is more than a month from now. So don't worry about that. Okay. The due date is so far away because I want you to get our feedback on your first lab, number 1. Okay. And then you can have a better idea about how to write a lab report. So you have better preparation for this lab. Okay. So due date is October 26th. Okay. Objectives of this lab is to determine the particle size distribution of the sand and also coarse aggregate, okay, by the SAVE analysis, and also to determine the bulk density of coarse aggregate. Okay. And here is the procedure. The procedure for the SAVE analysis of coarse. We need to get around 5 kilograms of coarse aggregate, okay, which is oven dry. And also we get the saves from 3/4 inch, half inch, 3/8 inch, number 4, and number 8 saves. Okay. From large to small size. So largest size on the top, okay, the smallest on the bottom. And also at the very bottom, we have a pan, which is collect all the fine particles after the save. Okay. We agitate the saves by using the shaker for 3 minutes, and then we determine the weight of each size increment. Okay, basically the amount of aggregate retained on each save size, and also retained on the pan. Okay, and then we transfer the weight into percentage, okay, and also to make sure the weight loss should be less than 0.3%. Okay, sometimes this is not very easy to achieve. So this is for the coarse. For sand, it's very similar, but the save size is different. From number 4 save, number 8, 16, 30, 15, and 100 saves. And also on the bottom, we have a pan, which collect all the dust. Again, shake for 3 minutes and determine the weight on each save size, and also determine the percentage of aggregate on each save size. And based on that, we can also calculate the fineness modulus of sand. Okay, based on this, we discussed that in the lecture of aggregate. The last lab is the bulk density of coarse aggregate. Aggregate should be dried, okay, and then we fill the aggregate, fill the container, which is about 1/2 cubic foot in volume. And this is a steel bucket. We fill the aggregate into steel bucket in 3 layers. And for each layers, we routed the aggregate with a steel rod for 25 strokes. Okay. And then we measure the weight of aggregate in that steel container. And based on that, we calculate the weight of coarse aggregate in a unit volume, which is 1 cubic foot. All right. So all these 3 tests are very simple. Okay, let's look at the test procedure from our previous TA, Risa. And this is the calculation. Okay, we calculate the percentage, the weight, percentage of aggregate retained on each save size, cumulative percentage, plot the gradient curve, and also calculate the fineness modulus of the sand, and finally calculate the bulk density of coarse aggregate, and also a couple of discussion questions for you to answer. Okay, so let's look at the video.
Take the properties of aggregate, sieve analysis, oven dry bulk density, and we go through two different sets of sieves for fine aggregates and then for coarse aggregate. And for bulk density, oven dry bulk density of aggregate, we're going to use this container, the steel container that we know the volume of it, that is half cubic feet. But before, I need to mention that yesterday I was here. I put all my aggregate inside the oven for 24 hours, 110 degrees Celsius, to make sure that we have all aggregates in oven dry condition. Because the parameter that I'm going to measure for bulk density is oven dry bulk density, and also for sand it's going to be very hard if you don't make your fine aggregates oven dried in oven dry condition, because it's gonna the particles stuck in the sieve holes, and then the measurement and preparing the curve is not going to be something accurate. Like before, just follow the instruction. The objective of this test is to determine the particle size distribution of fine and coarse aggregates. So what we are preparing ultimately is going to be a curve, two curves, one for fine aggregate and the other one for coarse aggregate, showing the distribution of particles of aggregate. And then figure out if we need to fix some part of the curve to be, in well-graded. You remember that, the well-graded aggregate? So we need to, test it in the lab, and let's see what is the deficiency of our aggregate. The first part of our experiment is sieve analysis for coarse aggregate. Make sure that you refer to page 560 of your textbook, experiment number 7, and to review the procedure one more time and get more details. I need to weigh 2.5 kilograms of 3F, the larger aggregate, this one, and 2.5 kilograms of the other one, because as you remember, we use two types of coarse aggregate inside the concrete. We want to have the properties of exactly the same material we use inside the concrete, the bulk density and also the curve for the particle distribution. So what I need to do is take a container and then weigh it. So I re-zero the scale in gram and put my container. Don't forget to write down every numbers in your records, because if for any reason we forgot this, forgot to re-zero the scale before adding the material, we have the number, we can just simply subtract it. So the number for the container I'm going to use for coarse aggregate is going to be 836.8 grams. And then I'll re-zero it. I need 2.5 kilograms of 3F coarse aggregate. So it is more than enough. Just set it on exactly 2,500 because it is in gram. So we can write down this number or just play with your aggregate to get right on the number. So my number is 2,500.2 grams. Because I want to add another 1.5 kilogram of another type of coarse aggregate, I just re-zero it and then add a second on top of my 3F aggregates. So I need it's okay for coarse aggregate to, just dump it on top of the first layer, but for, sand or fine aggregate, it's not a good idea to do something like this. I have to use another container and then add it to it. So 1 kilogram so far. I need to be, careful about not mixing two types of aggregate, because we want exactly two separate 2.5 kilogram of each. It is 1.6 something. To be as close as possible to 2500, a little more maybe. So you got this number 2500.5, 2500.6 now in grams. I have my sample of coarse aggregate, and it's time to use my sieves. What I need here, according to the instruction, I need 3/4, half, and then 3/8, number 4 and number 8 sieve stack, and then I need to weigh them one by one when it is empty without the aggregate, and then dump all the aggregate on top of my sieve pile, and then put them to shake them on the shaker. Make sure that the sieves number exactly is according to the instruction. So we have 3/4 on top because it's the largest, and the cap also, and I'm gonna weigh them one by one, including the cap and pan underneath. So the largest is 3/4, and then I have half, then I got 3/8. Double check the labels, that make sure that you are, stack them in right way. And then sieve number 4, that you remember that is the border between coarse aggregate and fine aggregate. And then number 8, because for any reason we might have some fine aggregate inside the coarse aggregate, that is okay. Actually, it's going to be better to have a smooth transition between coarse aggregate and fine aggregate inside the concrete, instead of just jumping from coarse aggregate to fine aggregate. So what I need to do is just weigh them and write down the numbers. Make sure that your scale is showing 0. So first, without aggregate, I just put a pan, empty pan, on the scale and write down the number 1280.3, and then put it here. The next sieve is sieve number 8. Make sure that it is 0, should be. It is 1258.2 grams for sieve number 8, and put it on the pan. And for sieve number 4, this number is going to be 1348.4. And for 3/8, the number is 1334.8. And 1/2 inch, the number is 1182.0 gram. And then 3/4 inch, 1398.1 gram. It's a good idea again to weigh the cap as well. So the cap itself is 1023.0 gram, because it is possible when I want to weigh my aggregates and sieve together, I forgot to take the cap out of the sieve 3/4. I have the number. I can fix my errors later. What I need to do is dump all the aggregate on top of the sieves, and then take the whole thing to the shaker. So I have 5 kilograms sample. You have the exact number. Do it gently because we don't want to lose any particle of our aggregate, because we're going to confuse at the end that we're going to check our error. And then put a cap and take the whole pile of sieves to the shaker to shake it for 3 minutes. Okay, so let's go to the shaker. Okay, I took all the sieves, including aggregate, here in the shaker. Just make sure that you tighten all the bolts correctly, because it shakes aggressively, and if not, just you need to redo it. When you're sure that it is tight enough, the bolts, you can turn on the machine. So it sets preset on 3 minutes. I just turn it on, and after 3 minutes it automatically stops. Okay, we've done with 3 minute shaking, and just open the bolts and take the whole thing to the scale one more time and weigh them one by one with aggregate this time. Okay, I'm going to weigh them, the sieve and the aggregate inside, one by one, and just write in the number. And for the first one, I want to, put the cap and the sieve number 3/4, the whole thing, and the aggregate inside on the scale. Let's see if we have any aggregates. So there is no aggregate inside. It means that all the aggregate, the coarse aggregate, was smaller than the size of these sieve number 3/4. But anyway, to do the whole procedure one by one, I put the cap on top of the sieve number 3/4 and weigh it one more time. So the whole thing is 2421.2 gram. I put it aside. On sieve number half, we have this amount of aggregate. So aggregate on sieve number half is 2313.8. Put it aside again. For the second sieve, sieve number 3/8, the number is 2368.9. And for sieve number 4, we have 3561.2. You can write it down. And sieve number 8 is 1833.5 gram. We can also see that we have a little amount of aggregate, but because we have the whole, the 5 kilogram, about 5 kilogram, and we need to compare the amount of aggregate retained on each sieve, sum them up, and then compare it with the 5 kilogram sample originally, we need to weigh it one more time. So the pan and it's actually the dust is 1324.4. You don't use it in your curve. We just make sure that we have a little amount of aggregate inside a pan. We've done with the first part of the experiment. For the second part of the experiment, we need to use that set of sieve for fine aggregates. So we need sieve number 4, 8, 16, 30, 50, and number 100. And the sample should be 1 kilogram. So I grab 1 kilogram of fine aggregate, I weigh it, and then the same procedure that I've used for coarse aggregate. I weigh my container when it's empty, put it on the scale. The number is 548.3.4 gram, and then re-zero the scale, and then grab 1 kilogram of fine aggregate. That is pre-dry in the oven. So my number is 1000.0, exactly 1 kilogram. And check the sieves. If you have them all, so I have sieve number 4 on top of them, following by sieve number 8, 16, 30, 50, and 100, and the pan underneath. And one more time, I need to weigh them one by one when it's empty without aggregate, and then dump the sample on top of them. Don't forget to weigh the cap. We might use it. So the cap is going to be 201.6 gram. Sieve number 4 is going to be 493.9. Number 8, 458.4. Number 16, 400.7. Thirty, 368.6. 50, 338.1. 'And sieve number 100, that is super fine, so you cannot see the holes even, is 315.8 grams. And also don't forget to weigh the pan itself. The pan is 365.5 grams. So make sure that the sequence of the sieve is exactly what you need, because it is supposed to have them from bottom to top, from smallest, finest to largest. So don't mess them up. So number 100 underneath the mold, following by 50, and then should be 30, and then the rest of them is correct here. I mean 16, 8, 4 on top of each other, and then put a pan after I dump the aggregate in them. So it's time to dump the aggregate. Be careful, be gentle, because I don't like to miss any particle of my sand. Once I make sure that the sieve sequences are right, I can dump the sample, 1 kilogram sand sample, into the sieves, in the sieve pile. Just make sure that you're doing it gently, because I don't like to miss any particles of the sand. Don't rush. Okay, I transfer all the particles of sand on top of the sieve pile, and one more time I need to take whole thing to the shaker and shake it for 3 minutes. Let's go to the shaker. So for shaking the fine aggregate, the only difference is that if I put a pile of small sieves on the shaker, I have this problem. So nothing supports the sieves in underneath part of the shaker. So what I need to do is put this ring first as a support of the sieves. So as you can see, I can support it better in this way, and then do the same thing. And then start the shaker for 3 minutes. Okay, it's time to weigh each sieve and aggregate inside one more time. I take the cap and put it aside, so I have some particles on top of sieve number 4. So because the sample was sand, was fine aggregate, it was supposed to have nothing on top of sieve number 4, because when we call that it's a fine aggregate, it means that we shouldn't have any particles of fine aggregate on top of sieve number 4. But it's okay. As I explained, it's not bad, because we're going to use coarse aggregate and fine aggregate together, and it is nice to have a smooth transition between coarse aggregate and fine aggregate. So just weigh it. You have the weight of the sieve number 4 when it was empty, and one more time I'm going to weigh it with aggregate, and then you need to subtract it to figure out what's the weight of these particles. So sieve and particles inside is 503.2 grams. For sieve number 8 and aggregates inside, the number is 599.5 grams. For 16, the number is 744.1 grams, 0.0 grams. For sieve number 30, so as you can see, as I go further, the particles are finer and finer, because the rest of them, I mean the coarser aggregate, retain on the previous sieves. So the number for sieve number 30 is 654.5 grams. And for aggregate retained on sieve number 50, the number is 437.1. And the last sieve is sieve number 100. The last sieve is sieve number 100. As you can see, is super fine. And if I put it on the scale, the number is 4117.9. I also have some particles, retained on pan, because I'm going to compare the whole number with a sample weight. I need to weigh it one more time and subtract with the weight of the pan. So 383.1. And I'm done with this part of the experiment. And as the last part, I need to have some calculation for the bulk density, oven dry bulk density of the coarse aggregate. Because the coarse aggregate I used in the concrete was the combination, 50-50, 50% of number 8 chips and 50% of 3F. I'm gonna wait. I'm gonna mix them 50-50 in a container, and then do the last part for you. For the last part, I need to weigh the steel bucket with noun volume, that is half cubic feet, and then tear the scale. So I know the volume of this steel bucket. It is half cubic feet. I put it on the scale when it's empty. So I'm going to use this one. So the weight of steel bucket when it's empty is 12.95 pounds. And then I turn the scale to 0. Then I need to do it in 3 layers. So like the concrete, the density of the concrete that we've done in previous experiments. I need to pour the coarse aggregate in 3 layers, ride it for 25 strokes, and then the second layer and third layer, and make sure that it is flat, and then weigh it one more time. So I'm almost here, 1/3 of the bucket, the steel bucket, and I can, stroke it for 25 times. Try to rub it all around the surface. The same for the second layer. Rub it 25 strokes. So like concrete, I need to, penetrate a little bit to a previous layer so I can take the rod something like this. So the total height from underneath my hand to the the tip of the rod is going to be 2/3 of the height of the bucket. Just make sure that you fill the steel bucket correctly, so we don't have to be beyond the height of the bucket, and also we don't want to have some part of a bucket without aggregate. What I'm going to do here is just get rid of the particle of aggregate that is beyond the height, and then fill the gaps, because I need to make sure that the bucket is totally filled with aggregates. Don't push it, just try to fill the gaps. Make sure that you're doing the experiment in the correct way, or you can do it one more time. So it is level and filled up. And it's time to weigh the bucket and the aggregate one more time. So the weight of the aggregate and the bucket, the weight was 0. So the number is just the weight of the aggregate, is 33.90 pounds. To make sure that I was right, I take the whole thing out of the scale. It should be minus 12.95 that is showing the weight of the bucket when it was empty. So you have the weight of the aggregate, you have the volume of your container that is half cubic feet. You can just simply divide these two numbers and get the oven dry bulk density of your coarse aggregate. And this is enough for today's experiment. So we have 3 parts for this experiment. We've done all of them. And you need to calculate the percentages of aggregate retained between each sieve and cumulative percentage of material passing each sieve, and just follow the instruction for the rest of them for the calculation part. And don't forget to discuss about the questions that you can see in discussion part. Okay, thank you guys. Today I'm going to test my aggregate for 2 important properties, a specific.
All right, so that's the second lab for today, guys. I think in general, Risa and the technician did a very good job. For this lab, it's very simple. Just based on the empty weight of the saves and also based on the saves with every weight, you calculate the weight of every weight on each save size. And from there, you can get the gradation curves and also the finest models of the sand. For the last lab, I'm going to double check for the volume of empty container. I think based on weight is 33 pounds. I suspect the volume of container is not half cubic foot. Okay, probably is 1/3. Okay, so I'm gonna double check with you and let you know the true volume of the container for the lab number for the last lab of today. Okay, so that's it for today. Do you have any questions about the labs?